Hello, Accelerated Math 6-7 students. Welcome to video 6, opening to our table of contents. I need you to enter in our notes for today, and it is called Tables of Equivalent Ratios and Ratio Table Structure. And we find this on page 19 in my comp book. So I'm going to turn there to page 19. And here is page 19. Again, you will notice that today we are working with equivalent ratios, and we're going to learn how to put them into tables. Okay, we've worked with tape diagrams so far, but we haven't done a lot with tables, so now today is officially the day that we're going to talk about equivalent ratios and ratios with tables. So tables of equivalent ratios and ratio table structure is the title. Please remember what I talked about in school today. You need to get your title on every page of notes that we write for each lesson. The goal, today we are going to learn what a ratio table is and how to work it. Okay. I really like ratio tables. They're a little bit quicker and a little bit easier to do than the tape diagrams. I don't know if I would agree that they're easier to use, but I like both of them. The ratio table is just faster. So the question is, what is represented on a ratio table? We need to be able to answer that question by the end of our lesson today. We're going to open up our lesson today with a task. The teacher wants to make paper mache for masks in art. Okay? I don't know if you guys have ever played with paper mache, but it's that gooey, wet stuff that you put on your face, and then when it's dry, you take it off and it's in the form of your face, so you can make a mask. It's really cool. She mixes water and flour to make this happen. For every 2 cups of water, she needs 3 cups of flour. Okay, so the first read is we're trying to figure out what the task is about. So I'm seeing that it's paper mache masks for art. So let's read it again, this time looking for the quantities. The teacher wants to make paper mache for masks in art. She mixes water and flour. For every 2 cups, so I would underline that if I were you, of water, she needs 3 cups of flour. Okay, 2 cups of water is a quantity, and 3 cups of flour is a quantity. And we know that because both of them have numerical values and units of measure afterwards. So we found the quantities. Okay, we need to read it one more time looking for the relationship. The teacher wants to make paper mache for masks in art. She mixes water and flour. For every 2 cups of water, she needs 3 cups of flour. So the relationship, and notice that's our first question, what is the ratio relationship for this task? So everybody should be able to do that. I need you to write down the ratio relationship, and the ratio relationship just happens to be in the task. For every 2 cups of water, she needs 3 cups of flour. You need to write that right here. Okay? All right. Moving on, it says list 4 equivalent ratios to the ratio from the task. Okay, so I'm going to get out a piece of paper so that I have room, and we can do that together. So we know that for every 2 cups of water, there are 3 cups of flour. Okay, so that is our ratio relationship. So if I was going to just write down the ratio, I would say that the ratio is 2 to 3. And I'm comparing cups of water to cups of flour. So the way I could set it up is I could say water to flour, and that would be 2 to 3, so that I know what it is. Okay? All right. Then the question said, list 4 equivalent ratios to the ratio from the task. So this is the ratio from the task, and we need to come up with 4 equivalent. Okay. So if we're coming up with 4 equivalent, could I say that all I have to do is multiply both of them by 2? Sure. That makes them equivalent. So we would say it would be 4 to 6. So that's one. Okay, another one, I could multiply both of them by 3. So that would be 6 to 9. And then the last one, I could multiply both of them by 4, which would be 8 to 12. So is that 4? No, that's only 3. So we need to do one more. So again, I'm just going to do one more. Let's go with 5. 5 times 2 is 10. 5 times 3 is 15, so it would be 10 to 15. So now I have 4 equivalent ratios connected to the original ratio that we see. Okay? All right, so then the next thing that asks us to do is, how could you organize these equivalent ratios? So I have them listed on the page, but this is getting kind of confusing. If you were just supposed to look at that and not know that it was a ratio, some of you might say that it looks very similar to time, 8, 12, 10, 15. So one of the things that we like to do is we like to use a tool to help us organize it. And the tool that we could use is, any ideas? I'm going to say, let's check out a tape diagram, maybe. Okay, that could be one. Another one that we could try is we could say a ratio table. Another one that we could say is a chart. Okay, there's lots of different ideas. Okay, is there a model that could help us? And the answer to that is, oh, I didn't need a comma there. The answer to that is yes. The model that we're focusing on today is the ratio table. Okay. So hopefully you're all with me. I'm going to turn the page, and we're going to talk about how you build a ratio table. Okay, so we have a ratio table, and I'm keeping this as our work so that we can see what we're going to do with it. A ratio table is a way to organize and show equivalent ratios. So here is the original ratio we started with, and then these are the 4 equivalent ratios. So we can put these on that table that you see. The way you build a table is you make it look like a letter T. So the top goes straight down, and then you make a line that makes the top of the T for table. And then these little clouds are very important. It says the independent value goes on the left side, and the dependent value goes on the right side. Now, some of you are thinking to yourself, I don't know what the difference is. The difference between an independent and dependent value means that one relies on the other. Independent values can be any value, and you don't have to have something else for it to exist. For example, most of the time, math information that would go on the X side or the independent side is time, because time passes whether we want it to or not. For example, right now I'm recording. I need to record 2 other videos, and I don't get to pause time in real life so that I have enough time to record. Time keeps going, whether I'm done with my videos or not. So usually, independent values are values that it doesn't matter if anything else is going on. That is still going to exist. Now, some of you are going, okay, I'm still trying to figure this out. Dependent depends on the independent to exist. So let's use my video example. Mrs. Nelson has 3 videos to tape. She has to use time to tape them. The video depends on her having time to do it. Do you see what we're saying? So if I don't have time, the video doesn't happen. Does that make sense? So we would say that the independent for this table, if we're talking about the videos I have to do, the time goes on the left side, and videos would go on the right side, because the videos depend on the time for me recording. Okay? That's an example. Let's go back to the task about the teacher and the paper mache masks. She wants to make masks with her art students, and we need to figure out, for making those masks, which one of these 2 items would be the independent and which one would be the dependent. Now, let's think about it. Do you always have water? Does water exist whether it's mixed with things or not? Yes, it does. If you always have flour, but flour is used to make things, and flour has to be combined with other things in order for those things to exist. So thinking about that, which do you think is a dependent and an independent amount or value? If you said water is the independent and flour is the dependent, I would agree, because the masks depend on the water in order for the flour to work. Does that make sense? So we're going to say that water would go on the independent side, and we're going to say that flour would go on the dependent side, okay? And so what you're going to do is, remember, what you do to one side, you have to do to the other. That comes in with making the equivalent ratios. So we're going to draw a table right here, and we're going to see what happens. Okay, let me make sure that I did do it down here. Okay, so we're going to make a table. Actually, it's already made for me. Sorry. So it says, let's make a table for the paper-mache relationship. So we know cups of water, we decided, was the independent because water always exists. And then cups of flour depend on the water to make the masks. Okay, so we know that for every 2 cups of water, there are 3 cups of flour. So we know 2 to 3. Do you recognize it? So here were our ratios. Do you see how we wrote it? Down here, we wrote the ratio as 2:3. On the ratio table, you put the 2 on the cups of water side, 2, 3, the cups of flour side. Does everybody see that? Okay, so that's how you list it in the ratio table. You don't list it with a colon anymore. You list it separated by that line of the table. Okay? So the equivalent ratios goes with this jazz hands rule. Remember, what you do to one side, you have to do to the other. So if I get to 4, the question is, how did I get from 2 to 4? How did I do that? I multiplied it by 2. What you do to one side, you have to do to the other. That's right. So I'm going to multiply 3 by 2. So what number would go in there? Okay, I'm going to redo the problem because I don't want to write in my book. But I have 2, 4, 6, 8, and then I have cups of water, H2O, and cups of flour on this side. And we knew the relationship was 2 to 3. How did I get from 2 to 4 times 2? 3 times 2 is 6. So now I have that equivalent ratio. How did I get from 2 to 6? I multiplied by 3. That is correct. What you do to one side, 3 times 3 is 9. Does everybody see what I'm doing? Okay, last one. How did I get from 2 to 8? I multiplied by 4. What you do to one side, you have to do the other. And so you get 12 on this side. Okay, and then the last one that we're going to do, because we wrote 4, what if we put 10 in here? So the question is, how do you get from 2 to 10? 2 to 10 is you multiply it by 5. What you do to one side, you have to do to the other, so this would be 15. All right, and now you have your first ratio table. The ratio table shows the original ratio, which is here, original ratio, and then all of these guys down here, right, all of these guys down here are known as equivalent ratios. Okay, and if you go back to our title in our notes, you will see tables of equivalent ratios and ratio table structure. And that's exactly what we've been talking about. Okay, I have one more question. What do you notice about the values? Well, we didn't even make the values. Do you think we could make the values from here? Okay, what is the value of this ratio? Remember, you just write it as a fraction. So this one would be 2/3. What is the value of this ratio? 4/6. What is the value of this ratio? 6/9. What would be the value of this ratio? 8/12. And this one would be 10/15. Now, remember, when we're working with value of ratios, we're talking about the fractional amount. So when you have fractions, are you supposed to simplify them into the lowest amount? The answer is yes. So can 4/6 be reduced? Yep, divide both by 2, you are correct, and you get 2/3. Wait a minute. Check those two out. Okay, could this be reduced? Yep, they both have 3, so we get 2/3 again. Oh my goodness, check it out, guys. What can go into both of these guys? Think 4, 2/3. Uh-oh, I'm noticing a pattern here. I hope the rest of you are. And then the last one, 5 goes into both, 2/3. So the question was, in the pink cloud, what do you notice about the values? And you all should be noticing right now that all of the values are the same. And if all the values are the same from yesterday's lesson, what do you know about all of the ratios? If the values are all the same, then they must be equivalent ratios. Okay? Hopefully you guys are understanding this a little bit more. There's one more page to our notes to check out. So again, I'm moving to a new page. I'm going to stand on this for a minute. Don't forget to write your title again on your new page. Okay? Sorry for the bell. The next one, the ratio tables use the multiplicative property when comparing columns. Columns are these two. This is a column and this is a column. So we use the multiplicative property when we're comparing the columns. So you're comparing the independent side to the dependent side. Okay? So let's look at this table again. We are going to do multiplicative property because we're comparing the columns. Does everybody understand that? So we're comparing the cups of flour to the number of pancakes. So it's a different scenario. It says that for every 2 cups of flour, you can make 10 pancakes. Interesting. So now remember, multiplicative means what you do to one side, you have to do to the other. Say it again. What you do to one side, you have to do to the other. So then we would go, okay, what if I have 3 cups of flour? Then I'd get 15 pancakes. If I had 4 cups of flour, I would have 20 pancakes. If I had 5 cups of flour, I would have 25 pancakes. If I had 6 cups of flour, I would have 30 pancakes. Now, some of you are going, how in the world did you figure that out? Well, here's how I figured it out. I went to the very first one, and I said to myself, how did I get from 2 to 10? Because they gave me that one. So for every 2 cups of flour, the number of pancakes is 10. So the question is, how did I get there? Well, I multiplied by 5. How did I get from 3 to 15? I multiplied by 5. How did I get from 4 to 20? I multiplied by 5. How did I get from 5 to 25? I multiplied by 5. How did I get from 6 to 30? I multiplied by 5. So we can see that this is multiplicative. That rule is what you do to one side, you have to do to the other. So what we're saying here is when you're going from the independent column to the dependent column, you have to use the multiplicative property. Okay? That's a requirement. Okay? Now we're going to switch it up a little bit because sometimes you do not compare the independent to the dependent. You actually compare rows to rows to see what happened that way. And that's something completely different, kiddos. This one is called ratio tables are using the additive property when comparing rows. And rows go up and down, okay? And so let's look at this one and see what we find. So again, we have the cups of flour, we have the number of pancakes, but this time, instead of comparing the left side to the right side, we're comparing the top to the bottom, okay? And you will notice that this is a complete table if you find a pattern of rules. So if we have 2 and we compare it to 3, what happened? That was plus 1. If we went from 3 to 4, what happened? Plus 1. If we went 4 to 5, what happened? Plus 1. 5 to 6, what happened? Plus 1. This is called additive because we're increasing by adding 1. Okay? Same thing on the other side to compare. If you go from 10 to 15, what did you do? You added 5. 15 to 20, you added 5. 20 to 25, you added 5. And 25 to 30, you added 5. So boys and girls, we're seeing that every time we moved, it's add 5, add 5, add 5, add 5. Every time we move on this side, it's add 1, add 1, add 1, add 1. This ratio table is considered a true ratio table because all of the changes match up. And let me explain that a little bit more. So if we went from 2 to 3 and we got plus 1, and we went from 10 to 15 and we got plus 5, and then let's say that we went from 3 to 4 and we got plus 1, but when we went 15 to 20, let's say it was a plus 8. So that would make this whole table inaccurate because your additive amounts have to be equal. Your additive amounts have to be equal. If they're not equal, then there's something wrong with your ratio table and you know you made a mistake. So that's another way to check to see if the ratio table structure is correct. Okay, so we learned about the multiplicative property. That's when you're comparing column to column. And we learned about the additive properties to see if the ratio table is correct by going row to row, making sure that you added the same amount between each one. Okay? Boys and girls, that's it. That's our entire lesson for today. So let's go back to check out our question. Our question said, what is represented on a ratio table? So hopefully you can answer that. It's kind of in the name. Think about it, okay? Also, it's kind of in the title. So if you go back up to the title, that can help you answer it. All right. So I think we answered all of the questions together. So I don't know if you have any classwork problems to work on for our lesson tomorrow or for our discussion tomorrow. So I think that's it. All right. Have a great evening, and I'll see you tomorrow. Bye.